Well, hello, Falcons. I hope everybody's doing well, and I hope you guys have your masks on with your noses covered. And I want to, Mrs. Sharp is out with COVID, so I will be out for a few days. So yeah, you guys take care of yourselves. And make sure you keep an eye on Octavia and Barbazeus while I'm gone, okay? Make sure they have enough water. And I'm sure that they're probably growing like crazy. So anyway, you guys had some homework to do on similar polygons. Now, I hope you're able to get through that without me. I wanted to go through this first example about similar polygons. Now, we know that when polygons or triangles are similar, that the corresponding angles of the similar triangles are equal. Remember, that was the CASTE. And the corresponding sides of the similar triangles are proportional. Now, I put similar triangles here in our acronym, but we know that that goes for all polygons as well. And then when we want the scale factor, what we're doing is we are looking for a pair of corresponding sides that have the numbers. So if I tell you that these quadrilaterals are similar, that means that all of their corresponding sides are proportional to each other. So to figure out what the scale factor is here, we have to look at the two sides that actually have numbers on it. So that would be the 4 and the 16. So 4:16 is going to be our scale factor, which reduces to 1:4. So the scale factor of these two is 1:4. So how are we going to solve for x? Well, we're going to set up a proportion. 1:4 as x is to 12. So that one works out kind of nice. 4x equals 12, x equals 3. Then for y, we're going to do the scale factor 1:4 again, as y is to 14. So 4y equals 14, y equals 14 divided by 4, or 7/2. Then for z, we're going to have 1:4 as z is to 8. So 4z equals 8, z is equal to 2. Okay, so then I asked you to do a couple homework questions, so I'm just going to pull a couple of those that we can talk about. So for number 5 on page 372, it says, what is the length of CD if these two figures, ABCD and PQRS, are similar? Well, we want to look for the pair of sides that will give us the scale factor. So I see we have BC, which is 6.25. So we'll have 6.25 is to the side that it corresponds with, which is QR, and QR is 10. So there is our scale factor. So if we wanted to find the length of CD, we would have 6.25 is to 10, as CD is to the side that it corresponds with, which would be RS, which is 8. So then cross multiplying, let me just grab my calculator here. We have 10 CD is equal to 8 times 6.25, which is 50. Well, that's pretty cool. So CD is equal to 5, just like that. Then for numbers 12 and 13, it says determine whether each of the figures is similar using similarity transformations. So we just need to know if the corresponding sides are proportional to each other, because it looks like since these are in the coordinate plane, we should be able to tell. This first one, they look like they're rectangles, and we can check the corresponding sides. 6 is to 3, as 2 is to 1. So that is a common ratio, so we're good to go. Then for this one, I see that we have one right angle, but I don't know for sure that the corresponding angles are equal, but I can certainly say that this is not possible when I look at the corresponding sides, because we would have 2 is to 4 as 4 is to 6. Is that a true proportion? No, those are not equivalent fractions. They don't have the same cross product. You can tell that it's not a true proportion. Therefore, they would not be similar to each other. Okay, next. let's see, we had find the scale factor of these two, very similar to the one that we just did previously. So we're going to look for two of the sides that match up here. So I'm looking at GF. Do GF and JK go together? No. Does what, let's see, which one would go with EF? EF and JK. So EF and JK looks like a winner. They are in matching positions in our notation. So notice how it says JKLM is first. So I'm going to have to put 20 first. So 20 is to 8 gives me the scale factor of, divide each by 4, we would have 5 to 2. So our scale factor is 5 to 2. So then we would set up proportions to figure out what X, Y, and Z are, and then we can find the perimeter of each polygon from that. So let's see if I can quickly do that for you so we can do, so we can actually find the perimeter. So 5 is to 2 as, where's X? X is to KL. KL is going to match up with FG. So we have 211. So we have 2x equals 55. X equals 55 divided by 2. And that's 27.5. Okay, so X 27.5. Now for Y, we're going to have, let's see, 5 is to 2. Again, my scale factor. As Y is HE, so that's going to go with JM, as 30 is to 4y plus 4. Now, cross multiplying here, we get 20y plus 20 is equal to 60. So then, let's see, 20y plus 20. Okay, so 20y equals 40, y is equal to 2. Okay, so if y is equal to 2, this is going to be a length of 12. So we have the perimeter of the smaller guy. So then if I have to find Z, I'm going to do 5 is to 2 as, wait, is there a Z? Maybe Z went here. Could that be? ML goes with GH. So 5 is to 2 as Z is to 3. Oh, I'm sorry. No. I see the Z now. Z is the angle E. So E and J go together. So Z is 65 degrees because the corresponding angles, remember, are equal. So if we have to find the perimeter, remember that the ratio of perimeters is equal to the ratio, or is equal to the scale factor. So I can see that the perimeter of the little guy is 11, 22, 34. So the perimeter of this is 34. So 5 is to 2 as X is to 34. So then 2X equals, what is that, 170? 34 times 5, 170. So then X is equal to 170 divided by 2 is 85. So that tells us that the perimeter of the big guy is 85. So is 85 to 34, is that 85 divided by 34 equals 2.5? So that looks pretty good. And is that the scale factor? So we know that we did it correct. Okay, so I'm going to try to make these videos not too long so that you guys don't have to suffer too bad. So it says just determine whether each set of triangles is similar. The only way that, well, we know right now is to show that all the corresponding sides are proportional and that the corresponding angles are equal. But we also had one way to prove that triangles were similar, and that was by showing that two pairs of angles are equal, or I believe that, well, hopefully if you guys read ahead, we had angle, angle for similar triangles, side, angle, side for similar triangles, and side, side, side for similar triangles. So angle means that if you have two pair of angles congruent, then that means all three are congruent because of the third angle theorem, meaning that the triangles are going to be similar. Then the second one is if you have two pair of sides proportional to each other and the angle included between those sides congruent, they're going to be similar. And then if we have three pair of sides that are proportional, the triangles are similar. So if we look at number 7, we're going to say yes. Those two triangles would be similar because they have these angles at B and E congruent. The two triangles share that angle at vertex C. But then also, if these two angles are equal, AB would be parallel to DE, making this angle and this angle equal because corresponding angles are equal. So we can see that all the pairs of angles are congruent. In number 8, we have angle Y and angle Q are marked equal to each other. So we have to look XY to PQ. XY to PQ would be 10:6 as YZ, which is 12, is to QR, which is 8. Do those two fractions reduce to the same number? Well, this would be 5:3. This would be, did I do that right? 10:6. XY is to PQ, 10:6. So that would be 5:3. And this would be 3:2. So this would be no good. So now